In our next few segments, we're going to look at the values of the trig functions in the four quadrants, but we're going to think about the angle that we're speaking about in terms of radian measure, not in terms of degrees. So what I'm going to do first here is I'm going to define what a radian is. And you're going to discover as we produce or think about this that 1 radian is about 57.3 degrees. And you're going to be more comfortable with an angle in degrees than you are in radians. But it's like saying that in 3 feet you have 1 yard. Those are different units of measure, but they are the same thing. So that's where we're going with this. So same topic as previously in Chapter 8, Section 2, but now we're doing the same thing in the radian measure. So we're going to be reminded of how to convert angle measure from degrees to radians and radians to degrees and back again. So that's this particular segment's going to focus on that. And then we're going to go ahead and do what we've done previously and find the values of angles when we're given the value of the trig function, but we're going to do that and find the angle in radians. So first, I'd like to have you look at this circle. So a radian is defined as the laying out the radius of a circle along its circumference. And so that's supposed to represent the radius of this circle. And for any circle, if you lay its radius around its circumference, you will find that you lay the radius around 6.28 times. Look, I'm close to 3 times laying this radius. That's probably a little bit far that time. So I'm laying the radius. There's 3 of the radiuses. Here's 4 of the radiuses. Here's 5 of the radius. Here's 6 of the radius. And I'm left with 0.28 right there. I was able to lay 6.28 radiuses around the circumference of that circle. That number sounds familiar. I wonder if it's the same thing as 2 times pi. Pi being 3.14, son of a gun. It is. That's where the equation for the circumference of a circle comes from. It's 2 times pi, or 6.28 radii, and when you multiply it by the length of the radius, that gives you the length of the distance around a circle. So with that, we call this spot right here 0 degrees, and if you go halfway around the circle to this spot, you're at 180 degrees. Well, that's also 3.14. So what I've written here is that there are pi radiuses in 180 degrees, or 123.14 radiuses, called radians, in 180 degrees. And if I go all the way around the circle, there are 6.28 radiuses in 360 degrees. This right here is a conversion factor, and right there. I'm going to use that to convert from degrees to radians. But before we do that, I just want you to take your calculator and I want you to take 180 degrees and divide it by pi. So half of a circle and divide it by 3.14. And when you do that, you're going to get 57.3. So I want you to see that when I draw this line in right here that represents a 57.3 degree angle, it's also represented by that 1 radii that gets laid around its circumference. So 57.3 degrees is also 1 radian. Again, 180 degrees divided by pi, 57.3 degrees is 1 radian. So you're going to have to get used to radians being between 0 and 6.28. That's kind of hard because you're used to being between 0 degrees and 360 degrees, so much smaller values. Let's go ahead and do some converting. So what I'm asking you to do is to convert 12 degrees into radians. Again, I'm going to keep doing this. Remember, 57-ish degrees is 1 rad, or 1 radian. The way I'm going to do that is I'm going to use the factor label method, and I'm going to multiply by pi over 180 degrees because these are equal things, just like there's 3 feet in a yard. This says leave your answer in terms of pi. In other words, don't get your calculator out. Just reduce this fraction, which is 12 over 180. Just reduce that and leave pi in your answer. I'm going to do this one time, and I'm going to break 12 into its prime factors. And 12 is 2 times 6. 6 is 2 times 3. And so there's the prime factors of the number 12. 180 is 2 times 90. 90 is 2 times 45. 45 is, let's go 3 times 15. 15 is 3 times 5. Hopefully I got those all correct. And I'm going to reduce. I'm going to remove 2 over 2 because it's equal to 1. I'm going to remove 2 over 2 because it's equal to 1. I'm going to remove 3 over 3 because it's equal to 1. And I've reduced this angle and written it in terms of pi, and it will be represented as pi over 15. Let's do this again. Let's multiply 225 degrees. And if you want, stop the video so that you can reduce the 225 and the 180. I'm going to this time, though, just say that 5 divides into 225. It goes in there 45 times. And 5 divides into 180 36 times. So I've reduced this to 45 pi over 36. Oh, shoot, I didn't go far enough. So now I notice that 9 goes into 45 5 times, and 9 goes into 36 4 times, and finally I have reduced this satisfactorily to be 5 pi over 4. In a second, we're going to go ahead and do this very same thing, but we're going to write this in terms of decimal values. Lastly, if you reduced this one by removing common factors, I would probably just say 2 goes into there 33 times, 2 goes into there 90 times. Oh, I just happened to notice that 3 goes into each of those. 3 goes into there 11 times. 3 goes into there 30 times. So it looks like I have a negative 11 pi over 30. So I'm just learning to convert an angle from degrees to radian measure. This is kind of meaningless to me at this point in time, but let's keep going. So let's go in the other direction. But before we do that, I'd like to have you start to get a feel for where we are in the rectangular coordinate system. So I'm going to draw the 4 quadrants. And I'm going to show over here that this is 0 degrees, this is 90 degrees, here's 180 degrees, here's 270 degrees, and I'm back to 360 degrees. But we just recently proved to ourselves that 180 degrees is the same as pi, or 3.14 radiuses. If this is 0 and this is pi, then this is half of pi. That's what 90 degrees is. Again, 0, here's pi, this is halfway, half of pi. Again, go over here, you get to pi. If you go all the way around, you're at 2 pi. So a whole pi, 2 pi. Then this right here is 1.5 pi. 3 over 2 is 1.5 pi. So when I'm speaking about 3 pi over 10, and I want to convert that into degrees, this is only 3/10, or 0.3 of pi. Here's pi, 180 degrees. So 3/10 of that is going to be, something about right there is what that's going to be. It's going to be an angle about that large. Let's go and figure out what it is. So to convert from radians to degrees, I have to multiply by the reciprocal, because using the factor label method, I've got to show myself that those pi radians will cancel out, and I'll have an answer in degrees. If you take your calculator and go 3 times 180, hit enter, divide by 10, or there is easier ways to do that. Just 3 times 18 would be the same thing. You'll get 54 degrees. Look at that red line I drew over here. Doesn't that look like about 54 degrees? So I'm trying to get you to start to recognize where I am. So I'm going to erase this, and let's go to the next one. 4 pi over 3. Well, pi right here is 3 pi over 3. That's just 1 pi. So if I want to go another third, 1 1/3, I'm going to go somewhere over here. And the angle I'm going to be looking at this time looks like it's going to be in the third quadrant. To do the conversion, I'm going to multiply by 180 degrees divided by pi. Easiest to just cancel those out. Yes, how about this? 3 goes into 180 60 times, and 4 times 60 is a 240 degree angle. Look at what I drew when we first started. Doesn't that look like about 90, 180, 240 degrees? It sure does. So could you start to recognize here's 0, here's half a pi, here's 1.5 pi, and 2 pi. So 9/2 pi is 4.5 pi, or 4.5 pi. Shoot, 2 pi is go around the circle once. 4 pi is go around the circle again. And I want to go another half a pi. So here's pi. So it looks like I'm going to stop right there, I think, for 9/2 pi. But let's go ahead and find it by using 180 degrees over pi. If you cancel those out and you do the work on your calculator, you'll get an 810 degree angle. So 360, 720, and if I add 90 to that, I'm at 810 degrees. That's coterminal angle to a 90 degree angle. Let's go ahead and just do a few more things. You know, find the measure of these angles in degrees. I don't actually want to do it because it's just taking pi over 6 and multiplying by 180 over pi. Canceling that out, and 180 divided by 6 is a 30 degree angle. But rather, what I want you to see, and I'm going to write this rather quickly, that this is 0, this is pi, this is half a pi, and I want you to see pi over 6 is right about here, because this would be 1/6 of the way to here. This would be right here, 2/6 of the way all the way to pi, which is 1/3 pi. So I bet you that angle right there is 60 degrees because I went 30, 60. Look, pi over 2. I'll bet you that's 90 degrees. 2 pi over 3. Let's keep going. So pi over 2 is also 3 pi over 6. I'm going to add another 6th. 4 pi over 6. Here's 5 pi over 6 at 150 degrees, and there's pi, which is 6 pi over 6. This 2 pi over 3 is the same thing as 4 pi over 6. I bet you that's 30 plus 60 plus 90 plus another, I'm sorry, I'm saying that wrong. Add 30, another 30 is 60, 90, 120. Bet you that's equal to 120 degrees. Wanting you to feel where these are at. Finally, if I was going to express an angle in terms of degrees, and I was given an angle that looks like this, because it does not have a degree symbol, I know that that angle must be in radian measure. And so I know that the conversion factor to do this, since this is in radians, I got to put pi down here, because there's 57 degrees. This is about 57. There are 57 degrees in a radian. So when you take 1.703 times 180 and divide that by pi on your calculator, you're going to get 306.54 degrees. Boy, something's wrong with that. So I'm not gonna fix. I'm gonna go 1.703 times 180 on my calculator divided by pi, and I typed it wrong. I apologize for this. And I get 97 degrees. I'm sorry, I wrote in my notes incorrectly. 97.6 degrees. Again, remember, this is about 3.14. This is about half of 3, so approximately 1.6 or so. And so 1.7 takes us right here to the 97 degrees. I'm going to pause and let you do the rest of these on your own. So you'll multiply by 180 divided by pi. This one's huge. When you multiply by 180 divided by pi, I believe, hopefully I'm right, you're going to get 5,729.6 degrees.